All right, in part B of section 2.3, we're looking at how to find an equation of a line given 2 points. This corresponds to your homework problems from section 61 to 80. We're going to use a slope-intercept form. This is the most common way to express the equation of a line. And in that form, y equals mx plus b, the y, the equal sign, and the x are, are always there. They're kind of like a constant. They get the generic part of the line. And the things that change are the m, which is the slope, and the b, which is the y-intercept. So when I look for the equation of a line, I can just write down y equals mx plus b and start hunting for the m and the b. So the y is a variable, so it just stays as the letter y in my final equation of a line, and it can represent any y that's paired with this x on a line. So y is the dependent variable. It represents the height of the point or the vertical axis, and the x is the independent variable. It represents the run, the x value. So any point x, y will be on this line that is represented by y equals mx plus b. So if I have a point here if I can plug in a point into x and y, then it'll be on this point for this, and this is the equation that represents that, any point on that line. All right, so let's start with an example. Let's do number 62 for an example. So my directions state, find the equation of the line given 2 points. And in number 62, our 2 points are right here. So whenever you want to find a line, the first thing you can do is start with that y equals mx plus b. And we need to hunt for the m and hunt for the b. So how do we find m? We talked about that in the previous recording. That equation is the slope, excuse me, which is rise over run, or the change in x over the change in y. So be consistent with, it doesn't matter which point you pick as the first point and the second point, but you need to be consistent. So the y goes above the x. So if I'm going to choose this as my first point, then I'm going to do the y and the x. And then minus, I'm going to remind you the formula for the rise over run. So that's change in y over change in x, which can be found by finding y2 minus y1 over, x2 minus x1. Make sure this is one of the ordered pairs and this is the other one. So there's my 5, 1 right there. I'm going to do the other one in green. Excuse me. Just a second. Okay, and then my other pair is the -4 and the -3. The y is -4. -3. The y is -3. The x is -4. I'm putting those in parentheses because I don't want to get that messy negative, so I want to know it's minus a negative, so I know it's going to become a plus. So double check, this is one ordered pair. So check vertically that you kept your ordered pairs together. There's one ordered pair, and then the blue one is the other ordered pair. And your y's are the ones in the denominator, and your x's are in the numerator. I mean, other way around, sorry. Your y's are in the numerator, your x's are in the denominator. Okay, now back to solving. So m equals 1 minus a -3 is 1 plus 3, so that's 4. Actually, I'll go ahead and write that step. And 5 minus a -4 is 5 plus 4, which gives me 4 over 9. So this is my slope. So remember I said that with this equation over here, the y, the equals, the x, and the plus are constant. So I'm just going to keep that here and just fill in the x and the b. Sorry, the m and the b. I just found out that m is 4/9. So now I just have to find out what that b is. What is b? The b is the intercept. So what is a y-intercept? When I have a line, I'm going to draw a quick axis here. Excuse me. And I'll draw a quick line on this axis. The intercept is that point right there. And so b equals the y value at that point. The y value when it intercepts the y-axis. So at that point, it's the x value is 0 and the y value is b. So at what height does the line intercept the y-axis? So let's find b. I know that this equation will hold true for every x and y value. So my task now is to figure out what b will work. And I know that I have a 1 point on the line. I know that that point is on the line. So I'm going to plug that point in. I'm going to do that off to the side here so that I don't interfere with my generic equation. So I'm going to plug in I'm just going to pick a point. Let's pick this one. Actually, let's pick the other one because I like positive numbers. So 5 and 1. So when y is 1, x is 5. And I have the slope of 4/9, and the thing I don't have is the b. But I can plug in that point 5, 1 into this x and this y. And I find another thing that's true. So now in this equation, the only thing I don't know is b, so I can solve for b. So I get 1 equals 4/9 times 5 is 20/9 plus b, and then solving for b, so I subtract 20/9 from both sides. So I'm going to re-express that 1 as a 9 over 9, so I have a common denominator to subtract. And I get a negative 11 over 9 for b. Now I take that b and I plug it back into that equation, the generic equation, where I had y equals and the x, and I plugged in my slope. My slope was 4/9, and my b-intercept, my y-intercept, which is b, I'm going to go ahead and change that. I mean, you know what? I did say I'm going to write that as I'll keep my plus sign there because I said that's part of the generic equation. And then b is a negative 11/9. So it's plus a negative, so I can simplify that to y equals 4/9 x, and I can say plus and negative is the same as minus 11/9. You might also see this expressed around like this, negative 11/9 plus 4/9 x. So what's important, because sometimes you'll see the slope and the mx and the b switched positions, but what's important to remember is that the m is always attached to the x and the b is the constant. So m is a coefficient, it's attached to something, it's attached to a variable, and b is a constant. The constant stands as a number that stands alone. Constant. It stands alone. There's no variable next to it. Okay. Sometimes I'll switch the order, especially when the slope is negative. But in this case, here's our best solution. Y equals mx plus b. my final answer.